Hello everyone, welcome back to Deeksha Karnataka YouTube channel. I hope you can hear me. I just check the comments. If you can hear me, please let me know. Hi. Yes, I'm here. So today what I am going to do, I am going to discuss the important questions that are going to come in your PU2 midterm exam, okay, and also I am going to discuss about some important MCQs, all the important questions that will come from this particular chapter, as well as I am going to discuss the important part where students make mistake, that is the numerical question. So everything will be discussed in this video. It will be about 2 hours. So drink the water, be ready. It will be a long lecture. Right. Hi everyone, can you hear me? Please let me know if you can hear me. Once let me silent my phone. Yes, okay. Hi everyone. Hi Harshvardhan, hi Aisha, hi Nagaraj. Hello. So first we will see what are we are going to discuss. We are going to discuss the chapters that is mentioned over here: electric charges and fields, electrostatic potential and capacitance, current, electricity, moving charges and magnetism, magnetism and matter, electromagnetic induction, alternating current, ray optics. These are the 8 chapters that we are going to discuss in today's lecture, one by one, chapter wise. So if you want to download the PDF of this session, you have to join our WhatsApp channel. The link of the WhatsApp channel is given in the description of the video. Most of you have joined, and we already have the link of the drive path, right? So you can download it from that same folder. I'll be shared in the same folder. If you don't have it, just join right now. Later on, the link of the PDF will be shared in our channel. Semiconductor, Khushi semiconductor is the last chapter of your PU board. Okay, it will not be there in the midterm. If it is coming for your midterm, for particularly for your college, may be there, but the district paper that you will receive, and based on what you will be scored for your overall performance will be judged based on the district level paper. In district level paper, I can guarantee you semiconductor will be not there. So we are not considering any individual colleges. They might say semiconductor is there in your midterm exam, but semiconductor will not be there in your district level paper. That is common for all students in that particular district. So for, if I say Bangalore South, all the students of Bangalore South will be evaluated based on the same question paper. If I say for example Chitradurga district, all the students who are under Chitradurga district, they will be all be treated with the same question paper. Okay, so in that district question paper, semiconductor will not be there. Okay, Khushi, clear? Okay, now if you have any doubts from the particular chapters, you can mention it in the chat. I will try to respond as much as possible. Now let's continue with the first chapter, electric charges and fields. So I will start with the MCQ questions. Charges are conservative for system, open system, isolated system, any system, no system. So this is a very interesting question. I often find that students find it difficult to answer. Let's see if you can answer this question correctly. Disha, wave optics again, as I said, it is not part of the most of the district. If your district have wave optics, we will try to cover it in another video, not in this lecture today, but if you have it, please mention in the comment section below. I will try to cover it in another video that will be coming out very soon. Okay, there will be more lives. We will be doing lives almost every day from now on, so you can get one of such videos. You will get wave optics in that as well. So first question, I can see most of you have answered it correctly. Aisha, Nagaraj, Manjula, Alien, Alt. So all of you have answered it correctly. Isolated system, yes, isolated system is the correct answer. So it is the correct answer, not any system. So Charges are not conserved for any system, it is only conserved for isolated system. Okay, so I have seen students many times make mistakes of answering any system. It is not conserved for any system, it is only conserved for isolated system. Next question, the SI unit of surface charge density is dash. So what is the SI unit of surface charge density? Okay, be careful, be mindful of the question, surface charge density. Pranav, I cannot read Kannada. Okay, alien alt is not alien. Okay, no problem. Pranav, you can type it in English. Okay, I can understand Kannada language, but I cannot understand Kannada texts. Okay, so that is a problem. Sorry, I am learning Kannada. So you can text me if you want in Kannada, but type it in English. Right? Surface charge density's unit is, okay, it is saying alien, not alien. Okay, thank you. Prabha, Shifa, Nagaraj is saying, all are saying option B. Yes, surface charge density is coulomb per meter square. So it is coulomb meter to the power minus 2, that is surface charge density. Line charge density, this is line charge, this is line charge density, and this is volume charge density. Okay, and this one has nothing to do, this is simple density is kg per meter cube, so this has nothing to do with it. So these two are these three you have to remember. Any one of them can come in your exam. I have taken surface charge density, but in the exam you might face line charge density as well as volume charge density. All three units are important, so you should remember what is what. Next is SI unit of electric field is Newton Coulomb, Newton per Coulomb square, Newton per Coulomb, or volt into meter. So what is the SI unit of electric field? Let's see who can answer this question. Pranav, it does not matter where I am from India. That's what, when I was teaching in classroom also, students used to ask me, sir, where are you from? I always say I am Indian, I am from India. That is what matters to me. It does not matter which state, which area, which place I belong to. It is more important that I am an Indian, and right now I am in Canada, so Karnataka, so I am a part of Karnataka, right? Yes, option C, everyone is saying option C. Yes, correct, option C is correct. Now remember that there is one more unit of electric field, that is volt per meter, or volt meter to the power minus 1, that is also considered to be unit of electric field. So just remember this unit as well. Okay, Newton per Coulomb is unit. If you consider from the perspective of electric potential, then volt per meter is also a unit of electric field. Next question, the angle between the dipole moment and electric field at any point on the equatorial plane. So angle between electric field and dipole moment. So suppose this is minus q, this is plus q. Okay, so angle between electric field on the equatorial plane. So suppose this is the equatorial plane. What is the angle between electric field and dipole moment? Now I am giving you one hint that dipole moment is always from negative to positive. Dipole moment is always from negative to positive. Option D. Students are saying option D. Yes, so always remember that for electric field it will be always in the opposite direction of the dipole moment. So dipole moment and electric field, they are actually in the opposite direction. So that means the angle between them is 180 degree, not 90 degree, not 0 degree, obviously not 45 degrees. So it is actually 180 degrees. Next question, the electric dipole placed in uniform electric field is unstable. Very important line. Okay, so electric dipole placed in an uniform electric field is unstable if the angle between the electric field and the dipole moment is 0 degree, 60 degree, 90 degree, 180 degrees. Okay, so there are basically three cases where electric so basically what happens here, suppose we have an electric field like this and we have placed some dipole, and it says that the dipole is unstable. Unstable means dipole has a non-zero force acting on it. Okay, the net force acting on the dipole is not zero. So what could be the possible angle between the electric field and the dipole moment? Now in one of these cases it will be perfectly stable, okay, otherwise it will be not perfectly stable, but again it will not be unstable, okay, it will be in the state of unstable equilibrium, but again it will be equilibrium in equilibrium condition. But if says it's completely unstable, that means the angle can be only possibly one value. Let's see. So Nagaraj saying option A, Gayatri saying option C. Let's see. Okay, I will give you few more minutes. Now if you see that at 0 degree definitely is not the answer, okay. 0 degree means dipole moment and electric field are in the particular same direction. It is a condition for completely stable equilibrium. The dipole will not even move. So this is a stable equilibrium. The dipole will not move, okay. Now if you can remember, the torque acting on it is given by PE sin theta, okay, PE sin theta. So torque can be 0 if sin theta is 0, that means theta equals to 0 degree. So this is a perfect equilibrium condition. This is a perfect equilibrium condition. Even though it is a not stable equilibrium, it is an unstable equilibrium, but still it is an equilibrium condition because sin theta still is 0, sin 180 degree is still 0. So correct answer is 90 degrees. It is the most unstable at 90 degrees. So this is the condition where it is most unstable. Actually it should be the option should be most unstable, okay. Most unstable means sin theta must be equals to 1. So that means sin theta 1 is at sin 90 degrees. So that means it will be most unstable. So correct answer is option C. So those who are saying option C is correct, not option D, Pano, because 180 degree is still stable. Even it is unstable, unstable equilibrium, it is still in equilibrium, okay. If you leave it at 180 degrees and if you don't disturb it, it will still stay at 180 degrees. It will not move, okay. But if you slightly move it from 180 degrees, then it will start moving, okay. So that is called unstable equilibrium. Stable equilibrium is where even if you displace it slightly, it will not move. That is 0 degrees. 0 degrees is a stable equilibrium, okay. 90 degree is the answer. 60 degree is in between 0 and 90. Even if it is unstable, it is not as unstable as 90 degree. 90 degree is most unstable. The question language should be most unstable. So most unstable is only at 90 degrees. Okay. Now if you are preparing for KCET exam, then Deeksha has currently launched KC90, an offline 90-day crash course. Okay, it will be focused for Comet K as well as KCET 2026 exams. So if you are interested, it is happening in our Deeksha campuses across Bangalore. So you can inquire if you are in Bangalore and if you want to participate in this crash course. Deeksha is producing toppers. 3 out of 1 topper is from Deeksha. So if you want to take advantage of the experienced faculties, then definitely you can contact this number given in your screen. Also remember that currently we are giving you an early bird discount of 3,000. But only you can avail it through this by calling this number. So you can call on this number if you are in Bangalore, and if you want to take advantage of this KC90, it will start I think first week of November. So you can join it. It will be completely weekend classes, so you will not, your regular classes will not be disturbed. So it will be completely we have taken care of all of your PU needs as well. So you can join it on this crash course which will be provided across Deeksha campuses. Now let's move on to the elaborate questions, 2, 3 marker and 5 marker questions which can come from this chapter. I am not going to discuss these questions. I hope that you will find these answers in either one of the guidebooks or my previous lectures. I have done the lectures on these chapters as well. So you can check on these questions. Okay, these are very common questions. You have to practice these questions anyway, especially the derivations. You should not miss out on the derivations practice. State and explain Gauss's law in electrostatics. Write Coulomb's law in vector form. Explain in the terms, or state and explain Coulomb's law. Sketch the electric field of the line due to a point of Q if Q is less than 0, Q is greater than 0. Define electric dipole moment, mention its SI unit, torque on an electric dipole, properties of charges, properties of electric field lines, electric field due to a dipole and axis on the equatorial plane, both derivations, electric field due to a charged straight long wire, electric field outside a charged spherical shell. So these are the chapters, these are the questions we have to practice it from this chapter. Now let's move on to the numerical questions, which are most of you are waiting for. So let us look into the numerical questions. I will be solving the numerical questions. In case I need some assistance from you, I will tell you that please do the calculation in the calculator, because I do not have any calculator. So I will obviously solve the question, but maybe sometimes in case of calculations I will ask you the answer. 3 charges each of equal to 4 nanocoulomb are placed at the 3 corners of a square of side 2 centimeter. Find the electric field at the 4th corner. Very common type of question which you can expect in your midterm exam. Okay, this type of questions are very common, where 3 charges are given and they asked you to what will be the electric field on the 4th corner, and generally it will be always square. Okay, if it is a rectangle, the problem will be slightly difficult and tricky, but otherwise it will be a rectangle. I have not seen anywhere they are giving it. Okay, so we have 4 charges, say 0.1, something happened, came back. So this is 0.1 having 4 nanocoulomb charge. This is 0.2 having 4 nanocoulomb charge. Okay, this is say 3. This will also have 4 nanocoulomb charge, and this is the point where we are trying to find the electric field. So electric field due to this positive charge will be away from, due to this charge it will be again away from like this, and due to this it will be along the diagonal. Okay, now because all the charges are same, okay, all the charges are same, it will be not a difficult problem. Okay, many students think this is a difficult problem. Actually it is not. First thing you have to remember that all the distances are 2 centimeter. 2 centimeter means 2 into 10 to the power of minus 2 meters. So this conversion is essential. This is applicable to all the problems. Remember that this distance will also be 2 into 10 to the power of minus 2. So as you can see, this charge and this charge, both charges are equal distance from the point of inspection. So we can say that electric field due to the charge 1 is equals to electric field due to charge 3, and that is equals to k cube by r square. Even though their directions are different, okay, the magnitude will be same, directions will be different, so we have to add them vectorially. It is a electric field is a vector quantity, so you cannot add them scalar form. So k value is 9 into 10 to the power of 9. Q is given as 4 nanocoulomb, 4 into 10 to the power of minus 9, and the distance, as I said, always take it as 10 to the power of minus 2 form whenever you are converting it into from centimeter to meter, to avoid confusion. 0.0, 0.02. So many students get confused. So if you use this trick, you will never be confused. You will always solve questions very quickly. Okay. Now last year there one problem happened. They want to give you some value. They mistyped it to one of the values, and student got confused. I hope that will not be repeated this year. So 9 into 4 divided by 4 into 10 to the power of minus 4. So 4 cancels, and 10 to the power of minus 4 goes up, and it becomes 10 to the power of plus 4. So this is the electric field Newton per Coulomb. Try to add the units whenever it's possible. That will help you to remember the answer. Okay. Now what about the electric field due to this charge? So this charge is number 2 charge. So number 2 charge electric field will be along this distance. Now distance will be different. What will be the distance for a square? If sides are A, each sides are A, then the diagonal is basically A root 2. Okay. Diagonal is A root 2, so it will be 2 root 2 into 10 to the power of minus 2, that is the distance. So electric field due to the second charge will be slightly different. It will be kq by r root 2 whole square. This root 2 is because of this factor. Okay, top part will be same, 9 into 10 to the power of 9 into 10 to the 4 into 10 to the power of minus 9. In the denominator it will be 4 into 10 to the power of minus 4. Okay, but there is a root 2 also, so root 2 square, so you have to add that as well. So in the multiplication form, so this will be cancelled, 10 to the power of 9 minus 9 cancels, and you get this as 4.5 into 10 to the power of 4 Newton per Coulomb. Now this is not the answer. Okay, you cannot simply add these two and get the answer because it's a vector addition, so you have to add them. Now this is our E1, this is E2, and this is E3. Now if you see that E1 and E3, they are perpendicular. Okay, E1 and E3 are perpendicular, also their magnitude is same. So the sum of E1 and E3, sum of E1 and E3 will be equals to, take any one magnitude times root 2. This shortcut is only applicable when both the magnitude is same and the vectors are perpendicular. This is a shortcut trick that I am teaching you. Okay, if the vectors are perpendicular and if their magnitude is equal, then their addition is simply E1 and E2, and their magnitude will be along the diagonal itself. So this is the direction of E13 as well. Okay, so now you see that E13 and E2, they are in the same direction. Now you can simply add them as scalar. So the net electric field is E13 plus E2. Now you can add them because they are in the same direction. Now you can simply add them. So it will be E1 root 2. E1 root 2 means this into root 2. So 9 root 2 into 10 to the power of 4. Okay, plus E2. E2 is 4.5 into 10 to the power of 4. Now 10 to the power 4 will be common. Okay, 10 to the power of 4 will be common, and you get 9 root 2 plus 4.5 into 10 to the power of 4, and the unit will be Newton per Coulomb. Now tell me the value of this quantity. Okay, even though I remember it, I am asking you what is the value. Videsh Ramanna Godor birthday inception. I don't understand what, sir. We don't want offline, we want online. Aisha, we will be launching online classes very soon. It is already under pipeline. Please wait for that. That will be launched. Don't worry. Now tell me the answer. Aisha, Shifa, whoever is available, use your calculator, maybe in your mobile, or maybe if you have a small calculator. And remember that scientific calculators are not allowed. Only simple calculators, non-programmable simple calculators are allowed for your PU board exams. Okay, but if you want to progress in future, try to avoid calculators as much as possible, because in KCET exam or NEET exam or JEE exam, whatever exam you will use, calculators are not allowed. So try to avoid calculators as much as possible. Now tell me the value of this sum. 17. Yes, Pano is saying 17. Actually it will be 17.22. If you take a little bit extra, it will be 17.22 into 10 to the power of 4 Newton per Coulomb. So let's check the answer. So it will be 17.22 into 10 to the power of 4 Newton per Coulomb. That will be the answer for this particular question. Now let's move on to the next question. A conducting sphere of radius 10 cm has an unknown charge. If the electric field 20 cm from the center of the sphere is 4.5 into 10 to the power of 3 Newton per Coulomb and points radially inward, okay, what is the net charge on the sphere? So first of all, it is said that the conducting sphere radius 10. Now remember, conducting sphere, okay, radius 10, okay, the distance is 20 centimeter. So distance is greater than the radius. That means electric field will not be 0, and we actually do not need this radius value at all. Excuse me. Sorry for that. So this 10 value is not required at all. Only thing we need is this distance, and because it is given in centimeter, we will write it like 20 into 10 to the power minus 2 meter. Okay, and the electric field is given. So we can consider the entire charge on this sphere as, say, Q. Then we can write the electric field at that point is given by excuse me. So it will be KQ by R square. Okay. Now this electric field says it is inward. So if the charge on this sphere is positive, then the electric field would have been outward, right? But it says it is inward. So inward means what? The charge must be negative in nature. So electric field, inward electric field means the electric field is negative. Remember this, if it is inward, then the electric field is negative. So that means this will be equals to minus 4.5 sorry for that, into 10 to the power of 3. Okay, so this will be the electric field. Now we will not use any negative sign on our left hand side, we will use the negative sign on the right hand side, because the electric field given is inward. So that's why we are using the negative sign over here. From here we can calculate Q. Q will be equals to minus 4.5 into 10 to the power of 3 R square divided by K. Now we will put the values. Minus 4.5 into 10 to the power of 3 R square is basically 20 centimeter, that is 20 into 10 to the power of minus 2. Now remember, there will be a square over here divided by the K value, which is 9 into 10 to the power of 9. Now we have to simplify it. It will be 2 here. Okay. Now continue. So here it will be 10 to the power of 3 into 20 into 10 to the power minus 2 whole square. 20 square is 400, and 10 to the power of minus 2 square is 10 to the power of minus 4. So it will be divided by 2 into 10 to the power of 9. Now if you consider every 10 to the powers here and the value here, so it will be 40 divided by 2 into 10 to the power of 9, and it will be 20 into 10 to the power of minus 9, that is 20 nanocoulomb. Okay, nanocoulomb. If you leave it here, you have to mark it as coulomb. If you are marking it as nanocoulomb, then you have to remove the 10 to the power of minus 9, and yes, it will be a negative. Okay, the negative sign was here, so it will be negative. As I mentioned previously, the charge is minus 20 nanocoulomb. If you miss the negative sign, they will be deducting 1 mark for that. Okay, clear? Now next question. A polythene piece rubbed with wool is found to have a negative charge of 3.2 into 10 to the power of minus 7 coulomb. Estimate the number of electrons transferred from which to which. So first of all, even if you don't know the electronegativity table, you can understand that polythene is getting negative. Polythene is getting negative means polythene is gaining electron, whereas wool is losing electron. So electron must be transferred from wool to polythene. So which to which is from wool to polythene. Right? Why? Because polythene is found to be negative. That means polythene has gained electron. So if something gains electron, that means the electron has transferred from the other object. So electron must have transferred from wool to polythene. So this is a part where you have to answer which to which. Now we have to use the quantization principle. Quantization principle means what? We know that total charge Q can be written as N into E. N must be an integer number. Now that value over here given as 3.2 into 10 to the power of minus 7. This is given. Now charge of an electron we already know, so n into 1.6 into 10 to the power of, try to solve it on your own, this is an easy problem, okay, 3.2 into 10 to the power of minus 7. The questions, numerical questions from this chapter particularly are easy to solve, that's why I recommend you always to solve numerical questions from this chapter, okay, divided by 1.6 into 10 to the power of minus 19. Even if you are weak in calculation, you can still use your calculator to find the final value, but the application must be correct, okay. You have to practice problems again and again to master this art. So number of electron will be 2 into 10 to the power of 12, okay. So this is a number, no unit is required, so number of electron which is transferred is 2 into 10 to the power of 12. There is a transfer of mass from wool to polythene. Now these many electrons are getting transferred from wool to polythene, right? So even if the electron is getting transferred, the mass of an electron, one single electron, mass of one single electron is about 9.1 into 10 to the power of minus 31 kg. Okay, so the mass that is getting transferred over here, you can calculate that, it will be very, very small. So mass transferred is negligible. This is part A. Part B will be mass of electron is very small. So mass of electron is very, very small. So the mass transferred is negligible. Okay, it is not 0, but you can, whatever is happening, you can neglect that. So 2 into 10 to the power of 12 number of electrons are getting transferred. It is transferred from wool to polythene, and mass transfer is negligible. You have to mention all these parts to get full answer. Okay, that's why I solving this question. Otherwise it's a easy question, but whenever you are solving, you might think okay, this is a easy question, how to answer it. So you have to mention all the parts properly to get full marks. I have seen students, they are writing it casually. You mention mark question number A, okay, after solving you have to mention wool to polythene is the transferred, and then you have to also mention that the transfer of mass is negligible to get the full answer. Now let's move on to the next chapter, electrostatic potential and capacitance. Again solve some MCQ questions. Okay, sir, will we get the PDF of this? Yes, Pano, I told you already. I told you already that you will get this question PDF in our WhatsApp channel. So if you have not joined our WhatsApp channel, you can join our WhatsApp channel and get the answer. Okay. Now let's see. The angle between equipotential surface and electric field is, equipotential surface and electric field, what is the angle between electric field and equipotential surface? Akshay is saying option A. Okay, let's see, option A is 90 degrees. So electric field and equipotential surface, so this is the equipotential surface, this is the electric field. So electric field and equipotential surface, they are always at 90 degrees. Remember this, no matter whatever is the shape of the equipotential surface, this is always 90 degrees. So 90 degrees is the correct answer. Yes, you are correct. Now next question, what is the total charge on the parallel plate capacitor? So here we have a parallel plate capacitor as shown in the figure. What is the total charge? Q, 2Q, Q minus Q, 0. Let's see. Yes, option A is correct. Gayatri, Nagraj, Mrudesh, Aisha, Pano, everyone was correct. Now let's answer this question. Total charge on a capacitor. So now everyone is saying again option A. Gayatri. So let's see. Okay, this is a very easy but tricky question. If there is a thing called total charge of the parallel plate capacitor, total charge, this is a very common question. I think this is from one of your either previous year question paper or from one of your previous model question paper. I don't remember, but it is a very common question which is coming, which might come in your midterm exam paper as well. So Q and minus Q, total charge, Q minus Q, that is 0. So total charge of a capacitor plate is 0. Option D. If they say charge of a parallel plate capacitor, if total word is missing, if the total word is missing, then the answer will be only the positive Q. Okay? If total word is not there, then Q. If total word is there, then it will be 0. Very, very careful. You have to understand that charge of a capacitor Q means that is only the positive charge. Okay, if I say total charge means it will be plus Q minus Q, that will be 0. Clear? Yes. So if they say total charge, it will be 0. If they said only charge, then that will be Q. So that's why I said this question is a tricky question but easy question. Okay, so if you see the question where what is the charge on a parallel plate capacitor, it will be Q. If it says total charge will be 0. Now next question. The capacitance of a capacitor is 6 into 10 to the power of minus 6 farad. It is connected to a 200 volt cell. The energy released on discharging it fully will be. So what is the energy stored in a capacitor? When you know the voltage, you know the capacitance. Okay. So what is the formula for energy stored in a capacitor? Energy stored is given by half C V square. Okay, this is the charge stored in a capacitor. Energy stored in a capacitor. So half C is given as 6 into 10 to the power of minus 6. V square will be 200 square. So it will be half. Let me cancel this 3. Okay. This is also one of the PYQs. Okay, 3 into 10 to the power of minus 6 into 4 10 20 30 40. So 2 zeros over here. So square means it will be doubled. So number of zeros will be doubled. So it will be 4 zeros. So it will be 4 3s are 12 into 10 to the power of minus 2. Why? Minus 6 was here. 4 zeros are here. So 4 zeros means plus 4 minus 6. It will be minus 2. So it will be 0.12 joules. The unit is joules. So 0.12 joules. So option A is correct answer for this particular question. So this is a small solving question, just simple one formula. So this kind of question is also expected in your midterm exam. If n identical capacitors of capacitance C is connected in series, then the equivalent capacitance is. What is the equivalent capacitance when you connect n number of capacitor in series? Okay, everything is connected in series. So what will be the equivalent capacitance? Let's see. Yes, correct, Muhammad, Nagraj, Gayatri, Aisha. Now Gayatri is saying option C. C by n. Any other option? Anyone else wants to answer? Muhammad is also saying option C. Yes. So if you connect n number of capacitance of C capacitance in series, then the equivalent capacitance will be C by n. If it is done in parallel, if the same question is asked, there is a variety of each question. If the same question is asked, n number of capacitor are connected in parallel, then answer will be C into n. Okay, it's get added, right? C plus C plus C plus C. So it will be C into n. In this case, 1 by C equivalent equals to 1 by C, 1 by C, 1 by C. So it will be n by C. Then you have to take the reciprocal. That will be C by n. So correct answer is C by n. Okay. Now next, if charge in a capacitor is doubled, then capacitance is doubled, halved, remains same, quadrupled. Charge in a capacitor is doubled, then what will happen to the capacitance of the capacitor? Okay, what will happen to the capacitance of the capacitor if the charge is doubled? Please answer it. Is easy question. Option A. Akshay is saying option C. Nagraj, Vishweshwari, Vishwanath Pujari, they are saying option A. Okay. Anyone else? Aisha is also saying option A. So if charge is a capacitor is doubled, okay, you have to understand that Q equals to C into V. So C is equal to Q by V. So if charge is double, capacitance should be doubled. But it is not the case. Why? Because capacitance for a given capacitor is constant. It does not depend on charge or on voltage. If you increase the charge, the voltage will also increase, so their ratio will be always constant. Okay, the capacitance only depends on the dielectric between the medium, the area, okay, epsilon naught is a constant, and the distance between the plate. So capacitance only depends on these three things: dielectric constant, area, and distance. Okay, so do not get confused. Even if you increase the charge or you decrease voltage, capacitance will not change. It will remain same. Only Akshay has answered it correctly, so it will remain same. Okay, it will remain same. Okay, Mrudesh also answered. I'm not sure. Mohammad, no. Half is also not the answer. Okay, even if you increase the charge, capacitance will remain same. Capacitor only depends on these three factors. It is independent of charge or voltage. So that's why I request you to read the NCERT carefully. It is mentioned in the NCERT textbook that capacitance of a capacitor is independent of its charge as well as its voltage. It only depends on its shape and size. Okay, shape, size, distance between the plates, etc. Now let us look into the 2 and 3 marker questions from this chapter. Equipotential surface, definition, shape of different cases, like for a point charge, what will be the shape of a equipotential surface? For a line charge, what will be the equipotential surface? Okay, what is the properties of equipotential surface? There are few properties, right? Like electric field lines, capacitance of parallel plate capacitor, combination of capacitors, expression for energy stored in a capacitor, energy density, potential energy of dipole in an external field, polar and non-polar molecules. These are the important questions. Difference between polar and non-polar. Okay, centers are same, centers are different. Potential energy of a dipole in an external field, the formula PE cos theta, that derivation. Now expression for electric potential at a point due to a point source at some point. This is very, very important derivation. Almost every year you expect this question. Electric potential due to a dipole, this is an optional. Okay, if you get some time, this is optional, you can study it. Okay, but for midterm this might come. In generally board exam this question never came, so that's why I say this is optional. If you get some time, you can study and prepare it. Otherwise this one has to be mandatorily you have to prepare. Okay. Now let's look into some numerical questions from this chapter as well. This chapter and the first chapter, okay, electric potential, electric charge and field chapter, and electrostatic potential and capacitance chapter. From one of these two chapters there will be numerical question. Okay, and from other chapter there will be derivation. So if the derivation is coming from electric field chapter, then numerical question will be from electrostatic potential and capacitance chapter. Okay, and if the opposite is happening, like if you are getting a derivation from electric potential and capacitance chapter, then numerical questions will be from electric field chapter. Okay, that is the common trend. That is how the question paper is being prepared each and every year. So first look into the question. Calculate the potential at point P due to a charge of 400 nanocoulomb located 9 centimeter away. Obtain the work done in moving the charge 2 nanocoulomb from infinity to the point P. Does the answer depend on the path along which the charge is moved? So let's see step by step. First we have to calculate the electric potential. The formula for electric potential is similar to that of electric field, but there is a twist: KQ by R. So don't get confused between electric field and electric potential. Electric field is only KQ by R square. Electric potential is KQ by R. Okay. So now let's put the values. Value of K is same, by the way. Q value is given over here, 400 nanocoulomb. So 400 into 10 to the power of minus 9. Nano means 10 to the power of minus 9. By this time you should know that. And distance is 9 centimeter away. So whenever there is a centimeter, there will be a 10 to the power of minus 2 to convert it into meters. Okay, so 9 cancels. 10 to the power of 9, 10 to the power of minus 9 gets cancelled, and you get the potential as 400 into 10 to the power of 2. This was minus 2, so this goes up and you get that as 4 into 10 to the power of 4 volt. Unit is important, electric potential. So electric potential means unit will be volt. Okay, now we have calculated the first part. This is the answer for the part A. Now part B we have to answer. So what is the work done to move a charge from infinity to that point of charge is given as 2 nanocoulomb. Now you have to remember that work done is given by the value of the test charge. This is called test charge. Test charge times the electric potential at that point. That is the work done. That is the definition of work done, right? Or electrostatic energy, electropotential energy. Okay. So the charge is given here as 2 nanocoulomb, so 2 into 10 to the power of minus 9, and electric potential that we have calculated is 4 into 10 to the power of 4, and the unit will be in joules. Because it's work done, it will be in joules. So here it will be 4 to the 8 into 10 to the power of minus 9 plus 4, 10 to the power of minus 5 joules. Now because electrostatic field is a conservative field, it is independent of the path taken. Okay, it is independent of the path taken, so it does not depend on the path on which it is moved. So you can think that suppose this is infinity, this is our point P, it is independent of the which path it took. It is independent of the path. Path means this is called path. Okay, the path you took to reach from infinity till this point. So it does not depend on which path you have taken. It is independent of the path. Okay, because electrostatic field is a conservative field. So you have to remember that point as well. So don't miss out on small answers. So I have seen students, they have answered this question correctly, but they forgot to answer this particular portion. So marks will be deducted if you are not answering perfectly. So answering perfectly is a very, very important part of your exam. Now next question, 3 capacitors of capacitance 2 microfarad, 3 microfarad and 6 microfarad are connected in series. Determine the effective capacitance of the combination. Now I am leaving it to you. You solve this first portion quickly and tell me the answer. Okay, what is the formula? Formula is 1 by C equivalent equals to 1 by C1 plus 1 by C2 plus 1 by C3. So this is C1, this is C2 and this is C3. Okay, diagram is not necessary, but if you can draw the diagram, that will be very, very good. Mohammad Muki, good evening. Afsara. Nagraj is saying yes, correct. Everyone is solving this question correctly. Yes, Mohammad. Mohammad, answer this question. Now 5 by 6. No, 5 by 6 is not correct. 5 by 6 is not correct. Check your calculation once more. So it will be 1 by 2 plus 1 by 3 plus 1 by 6. Okay, but remember this is 1 by C equivalent, so eventually you have to take the reciprocal, okay, or inverse. So the common LCM is 6, 3 2s are 6, 3 2s are 6, 6 1s are 6. Okay, so it will be 3 plus 2 5, 5 plus 1 is 6, so 6 by 6, so it will be 1. Okay, so C equivalent. Now reciprocal of 1 is also 1, so it will be 1 microfarad. Okay, so the C equivalent is 1 microfarad. Okay, Mohammad, you made a mistake. What mistake you made? You forgot to add this 1, I guess. Okay, that's why your answer is slightly wrong. Okay, Aisha and Apsara are answering it correctly. Gayatri, Akshay, they have all answered it correctly. 6. Mohammad, you answered it fast, but you should be careful. I think you missed out this 6 microfarad. You only taken this 2 and 3. You missed this 6 microfarad. There is 3 capacitors, not 2. Okay, you added them. 2 to the 6 divided by 5, right? But that is not the case here. Here we have 3 capacitors, not 2. Okay. Next is find the potential difference across 6 microfarad capacitor if the combination is connected to a 60 volt supply. So now circuit diagram makes sense. So I will draw the circuit diagram as well. Okay. Okay, here is the 60 volt, C1, C2, C3. This is 6 microfarad. So you have to find the potential across this 6 microfarad capacitance. So how to do that? They are connected in series. Connected in series means the charge that is flowing through each of the capacitor will be same. Okay, so Q is same for all the capacitors. Now what is the formula for Q? Q can be written as C equivalent into the potential that you have applied. Okay, this same charge is applicable for equivalent circuit as well. So for equivalent, if you can calculate the equivalent capacitance, we can calculate the charge, similar to that of current in case of combination of resistances, right? If you can calculate the equivalent resistance, we can calculate the current. Similarly, we can calculate the charge when we are considering the equivalent circuit. So charge we will calculate from here. So that is given by 1 microfarad. 1 microfarad means 10 to the power of minus 6, and voltage is given as 60. We will not multiply, we will leave it as it is. Okay, so this is the charge coulomb, this is the charge, that is total charge. Now the same charge is passing through this C3 as well. So if the voltage across this one is given by V3, then individually Q is equal to C1 V1, Q is equal to C2 V2, and Q is equal to C3 V3 is also applicable. So Q equals to C3 V3. This V3 we are trying to find out. Okay, so charge we have calculated 1 into 10 to the power of minus 6 into 60 equals to, now C3 is given by 6 microfarad, so 6 into 10 to the power of minus 6, and V3 we are trying to find. So this will be V3. So V3 will be 10 to the power of minus 6, 10 to the power of minus 6 gets cancelled. So V3 is 60 divided by 6, which is nothing but 10 volts. So 10 volt is the voltage across this one. Okay, voltage across this capacitor. Okay, so this is the technique. Technique is first equivalent, find the equivalent capacitance, then use the equivalent capacitance to find the total charge that is flowing in the circuit. Now by the principle of conservation of charge, because they are connected in series, charge through each of the capacitor will be same. Whatever charge is passing through C1, same charge has to pass through C2 and C3 as well. Now for a given capacitor, we know that individually charge equals to C into its voltage. Okay, so C into its voltage is same applicable for this C3 as well. Obviously C3 value is different, the V3 value will be different, it will not be the 60 volt obviously. So you have to apply the first, using equivalent capacitance, find the charge, that same charge you use to find the voltage. Okay, easy technique. Remember this technique, obviously in the exam values will be different, but similar question, there is a possibility that similar question will be coming. So 1 microfarad, 10 volt, straightforward answer. Now next question. In a parallel plate capacitor with air between the plates, each plate has an area of 12 into 10 to the power of minus 3 meter square, and the distance between the plates is 3 millimeter. Calculate the capacitance of the capacitor. Take epsilon naught approximately 9 into 10 to the power of minus 12. This approximation is given to you, so you can use that. So what is the formula? I just told you the formula. C equals to K A epsilon naught divided by D. This is the formula for capacitance of a parallel plate capacitor. Now here it is mentioned, it is air capacitor. So air means K air is equals to 1. Okay, the dielectric constant of K air is 1. Now put these values and tell me the answer. Okay, put these values, calculate it and tell me the answer. Now this K is dielectric constant, this is not Coulomb constant, so don't make it mistake and put the value 9 into 10 to the power of 9. This is 1. This is dielectric constant. Okay, unfortunately symbols are same. Area is given here 12 into 10 to the power of minus 3. okay, and epsilon naught value they asked you to take this value, so 9 into 10 to the power of minus 12 divided by the distance. Distance here is given as 3 millimeter. Now centimeter to meter is 10 to the power of minus 2, millimeter to meter is 10 to the power of minus 3. So here you have to be careful and make this adjustment. Okay, so this is the major part where student make mistakes. Trust me, if you are wondering, major students, many students make mistakes over here. They put the values correctly initially, but when converting from centimeter to meter or meter to millimeter, millimeter to meter, they make the mistake. Okay, they forget to add this 10 to the power of minus 3 value. Okay, so it will be 3 3s are 9, 36 into 10 to the power of minus 12. Yes, Nagaraj, you are correct. No, Nagaraj, you made small mistake. 36 will be the answer, not 3. Yes, correct. Afsa, what are you saying, Afsa? Yes, Afsa. Good evening. Yes. Not, Aisha, check the calculation. It will be, it is slightly wrong. You make some small mistakes, Aisha. Check it. It will be 12 into 3, which is 36 into 10 to the power of minus 12, not minus 24. I think you make some square somewhere. Okay, some mistake you have made. You may have squared some of the values. There is no square involved here. Okay, all the values will be directly added. So 36 into 10 to the power of minus 12 farad or 36 picofarad. If you can answer it, fine. If you cannot, if you leave it here, also full marks. If you mention picofarad, that is also fine. Okay, so answer will be 36 picofarad. Let me have some sip of water. Then I will continue with the next chapter. Okay, now let's move on to the next chapter, electric current. This is also an important chapter. The value of internal resistance of an ideal cell is. Yes, Nagaraj. Yes. Okay, the value of internal resistance of an ideal cell is. Now I have to go little faster. Okay, I have to try to wind it up by 7. So for that I have to cover a lot of chapters, but there are not many chapters with numerical, so that is one good thing. So this is also a very important chapter where you can expect numerical questions. One guaranteed numerical will come from this chapter. So the value of internal resistance of an ideal cell is 0. Okay, not D, not infinity. Internal resistance of an ideal cell is 0. Small r equals to 0. Okay, you are confusing with voltmeter and ammeter. Okay, ideal cell means it's a cell. Okay, so ideal cell generally do not have this resistance, right? So that is why we say ideal cell. That means it is 0 resistance. Okay, so ideal cell only has this, extra resistance is not there. So that's why, that means the value of small r equals to 0, not infinity. When current flows through a conductor, its temperature increases, decreases, remains same, may increase or decrease. Conductor is given, yes, 0. 0 is the answer. Now tell me the answer for this particular question. Increases, decreases, remains same, may increase or decrease. When current flows through a conductor, current is flowing through a conductor, what happens to its temperature? Tell me the answer. Option A. Yes, when current flows through a conductor, temperature will always increase. Okay, its temperature will always increase. It is not decreases. If it is a conductor, it will always increase. There are certain conductors, if you pass the current through them, it might decrease, okay, but for normal conductor, it will always increases. Conductor is always increases. There are certain types of material, I will not say them, tell them as conductor. There are certain materials through which if you pass that current, temperature can be decreased, but normally temperature will always increases for a standard conductor. SI unit of current density. SI unit of current density, ampere per meter square, ampere per meter cube, ampere into meter. This is also a previous year question. Mohammed, you can ask this type of questions after the lecture is over. Okay. Now tell me, Nagraj, Gayatri, everyone said, Mohammed Ibrahim saying option B. Anyone else? I'll take. Mohammed Mukid is also saying option B. Yes. SI unit of current density is ampere per meter square, not ampere per meter cube. Okay. Students get confused between normal density, mass density and current density. Current density is basically current divided by area. It's an area density. Okay. Current divided by area. So it is ampere per meter square. Next question. The magnitude of drift velocity per unit electric field. So magnitude of drift velocity per electric field is what? It is mobility, drift velocity, relaxation time, resistivity. Yes, yes, option A is the answer. This is called mobility of the electron. Next question. Which of the following characteristics of electron determines the current in a conductor? Thermal velocity alone, drift velocity alone, both thermal and drift velocity, none of the above. So current, on which of the factor current depends? Current, which of the factor the current depends? Thermal velocity alone, drift velocity alone, both thermal and drift velocity, none of the above. So obviously you can say that this one is incorrect. Obviously one of them depends. So out of these three, which is correct? So Mohammed is saying option C, Ibrahim saying option B, Nagraj is saying option C. Yes, option O. So it will be. So very interesting question thing. Remember the expression for current. Expression for current, NEA VD, that is the current through a conductor. Is there any thermal velocity involved here? Thermal velocities are random and they will always average out and it will be zero. Average of thermal velocity will always be zero. Only thing that depends, matters is that drift velocity. So it depends only on drift velocity. So those who answered option B is correct. Nagraj, you are unfortunately wrong. Aisha, you are also wrong. Akshay, Muhammad, Ibrahim Jia, you are correct. Okay, Marudesh, you are also correct. So option B is correct because it depends only on drift velocity. Current does not depend on thermal velocity. Okay. Now, next, let us look into 2-3 marker question. From this chapter, questions are very straightforward and easy. Drift velocity, write down the expression for drift velocity. What is mobility? Write its unit. Relaxation time, write its unit. Okay, so drift velocity, mobility, relaxation time, by the way, unit is second. Because it's time, unit is second. Expression sometimes they might ask. Limitations of Ohm's law, 2 limitations of Ohm's law, 3 limitations of Ohm's law. Difference between current and current density, that is also easy question. So what is the relationship between resistance and resistivity? R is equal to rho L by A. So that is also sometime might come. Cells in series and cells in parallel derivation, important. Wheatstone bridge is also very important. So both the derivations from this chapter are important. You can expect one derivation from this chapter as well. Wheatstone bridge is most common, but cells in series and cells in parallel will also come in some of the district. Based on the district, obviously some district will prefer Wheatstone bridge, but there are districts where you might can get cells in series and cells in parallel. Now cells in series is easy. Cells in parallel is slightly tricky. You have to practice the cells in parallel combination. Wheatstone bridge is also very easy. If you are following my trick, I have shared a trick where you can answer Wheatstone bridge is very 3 to 4 line derivation. Okay, so you can check that out. Current electricity chapter, I have discussed the derivations there. Now this is a new question. Let's see. This is a last year midterm PYQ. Okay, this is a midterm PYQ. So let's solve it. This question came in the midterm. In the following network, find the currents I1 and I2. Okay, so here we have EMF of the cell 12 volt. Okay, resistance given as 2 ohm. Okay, 2 ohm. Current through this branch is I1. Current through this branch is I1 plus I2, and current through this branch is I2 only. Now what we are trying to find? We are trying to find I1 as well as I2. So how to solve this question easily? Now if you see that there is no resistance connected in the lower part of the circuit. Okay, so I1 current exits a battery or cell, that means the same current has to come back. That is the conservation of charge. Okay, so if I1 current exits, I1 current will also come back. So current through this small r1 is again I1. Okay, current through this capital R 4 ohm is I1 plus I2, and there is no resistance in the lower part. Now we have to consider how many variables are here. We have I1 and I2, two variables. That means we have to construct two equations and then solve it. So how to do that? Here we will consider two loops and apply Kirchhoff's loop rule or Kirchhoff's current law, Kirchhoff's voltage law, sorry. So we will start from this battery. Okay, we will pass through this resistance and we will come back to the same battery. That is how one loop. This is one loop, loop number 1. Again we will consider, so we will start from the second battery. We will again pass through this resistance and come back here, and we will call this as loop number 2. Okay, you can follow any direction. Direction is not important for Kirchhoff's voltage law as long as it's a closed loop. Okay, so now we are passing I1 current through this, right? So let's apply Kirchhoff's voltage law. First resistance which we are facing is this one, R equals to 4 ohm. Current through this 4 ohm is I1 plus I2. So resistance times the current, that is the voltage drop across this resistance. Okay, so this is the voltage drop across this resistance. Is it over? No, it is not over. We have to go back and we have to pass through this 2 ohm resistance as well. Now through this 2 ohm resistance, what is the current? Current is I1. Now are we going in the direction of the current? Yes, we are going in the direction of current. That means it will be positive. If we are going in the opposite direction of current, it will be negative. So it will be 2 into I1. Why I1? Because only I1 current is flowing through this resistance. Okay. Now, are we going in the direction where the battery is trying to send the current? Yes, battery is also trying to send the current from positive to negative. So we are going in the same direction, positive to negative. That means it will be positive 12 volt. What is the battery connected here? Battery connected here is 12 volt. So it will be plus 12 volt. Okay, why plus 12? Because we are going in the same direction as the battery's current. Okay, now if you see that 2 is common in each term, so we will take 2 common and we will divide it. So we get 2 into I1 plus I2 plus I1 equals to 6. So we divided each term with 2. Now let's simplify. We get 3I1 plus 2I2 equals to 6. Be careful while breaking these brackets. 2 into I1, 2 into I2. Okay, so 2I into I1 plus I1, that is 3I1, 2 into I2, 2I2. So this is equation number 1. Okay, similarly we will apply the same Kirchhoff's rule. Here we applied the Kirchhoff's rule in loop number 1. Now we will apply the same Kirchhoff's loop rule for loop number 2. Loop number 2 is easy. Here only one resistance is there. So current passing through this is I2. Okay, and it is passing through this resistance which is 4 ohm. So 4 into I1 plus I2. Now we are trying to close this loop. No resistance in this branch. So no resistance in this branch means plus 0, and that will be equals to the voltage of the battery 6 volt. Why 6 volt? Because again we are going in the same direction of the current that is being passed by the battery. So if you are going in the direction of the current, okay, then it will always be positive. In case you are going in the opposite direction, then it will be negative. Okay, that will be complicated JEE level question. Okay, complicated JEE level question, there you will find cases where it is actually opposite direction. Now let's solve it. 2I1 plus 2I2 equals to 3. So what we have done, we have divided each term by 2 again, and this is our equation number 2. Now we have to simplify and solve these two equations. 2 variables, 2 equation. So what we will do, we will subtract 2 from 1. So 1 minus 2 we will be doing. So if you see that this is plus, so you will be simply I1, I2, I2 will be cancelled automatically. So 3I2 plus 2I2, 3I1 plus 2I2 equals to 6, and 2I1 plus 2I2 equals to 3. Now subtract them, minus, 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 it cancels. You get I1 equals to 6 minus 3, that is 3. So I1 equals to 3 ampere. This is our answer number A. This is our answer number A. Okay, now we have to put this value of I1 in any one of the equation and find I2. I will be using equation number 2 because this is small and easy. So from equation number 2, we get 2 into 3 plus 2I2 equals to 3. So 6 plus 2I2 equals to 3, or 2I2 equals to 3 minus 6 equals to minus 3, or I2 equals to minus 3 by 2. The board is freezing again, sorry for that. Here we are back again. Okay. So it will be 3 by 2. Now don't worry about this sign of the current. Do you know why? Sir, I1 is 3, I2 is minus 6 by 4. Yes, 3 by 2. Yes, correct. So do we have optics and semiconductors also? I am covering optics. Semiconductors is not part of your midterm syllabus. Okay. It is not part of any district because no one is expecting you to complete the entire syllabus. Okay, district syllabus, it is not there in the district question paper. It might be there in your, if the question paper is being set by your college, then it might be there, but otherwise semiconductor is not there in your midterm syllabus. Be confident about it. Okay, some colleges have, obviously colleges will try to cover the syllabus as early as possible and focus on your competitive exams. Some colleges might have semiconductors, but the main paper that you will be answering from your district, that will not have semiconductors for sure, guaranteed. Okay. Now don't worry about this negative sign. You might find in many cases, if you are solving the questions, the current can be negative. What is the meaning of negative current? Meaning of negative current is that current through the direction that you have assumed initially is opposite. That's it. Okay, negative current means the current is flowing in the opposite direction. Okay, it can possible because this battery is higher voltage than this battery, so this battery will dominate. So basically I2 is in the opposite direction. That's it. Okay, so the negative current, don't get afraid, oh my current is coming negative, this must be, I must have made some mistakes. No, you have not made any mistakes. It is quite possible current to be coming out to be negative. Okay, because the direction is only opposite. Okay, so those who are following my lecture, they should be able to answer this kind of questions. Clear? Any doubt? Murdesh, yes, it is there in, maybe as I said, it will be there in your college question paper. College teachers are answering the asking the questions, it will be there. But if the paper that you will receive from the district, that you have to compulsorily attend and answer those questions. Okay, that there is no other option, because your marks, especially for your maths and language subjects, the 10 internal marks that is being counted, that will be based on your district paper only. Okay, so be aware of that. 3 resistors, 2 ohm, 3 ohm, 6 ohm are combined in parallel. What is the total resistance of the combination? Some colleges do take 2 midterm exams. Okay, one is set by the internal teachers and one is by the district board. District board is compulsorily to be answered by all the students. So if you are answering, this is for district board paper only, okay, which is important. 3 resistors, 2 ohm, 3 ohm, 6 ohm are combined in parallel. What is the total resistance of the combination? Now this is similar to that question. There is a difference. If the combination is connected to a battery of EMF 2 volt and negligible internal resistance, determine the current through each resistor and total current drawn from the battery. So here we have 3 resistors connected in parallel. Okay. So what is the equivalent? And then we have a 2 volt battery. We have to find the current through each of them. So say I1, I2 and I3. Okay, so this is 2 ohm, this is 3 ohm, this is 6 ohm. Okay, now let us discuss this. What is the equivalent capacitance? Equivalent resistance. So equivalent resistance is same, that is 1 by R1 plus 1 by R2 plus 1 by R3, which is equals to 1 by 2 plus 1 by 3 plus 1 by 6. So it will be 6, 3, 2, 1. 6 by 6. So 1. So R equivalent is 1 ohm. So R equivalent resistance of the circuit is 1 ohm. Now what is the current through each of them? So current through each of them is I1, I2, I3. Now voltage should be, in case of parallel combination, voltage remains same. In case of series combination, the current remains same. So voltage same means same 2 volt is applied across each of the resistor. So from there we can say that 2 into I1 must be equals to the voltage that we have applied. So I1 equals to 2 by 2, that is 1 ampere. I2 will be 2 by 3 ampere and I3 will be 2 by 6 ampere, that is 1 by 3 ampere. So what is the total current? Total current I equals to I1 plus I2 plus I3, which is 1 plus 2 by 3 plus 1 by 3, which will be 2 ampere. So this is how you solve it. Okay, so 1 ohm, 1 ampere, 2 by 3 ampere, 1 by 3 ampere and 2 ampere. So you have to answer all these parts to get full marks. Okay, then only you will get full marks. Now circuit diagram is necessary for this question. Okay, otherwise you have to describe everything too much. If you mention everything in the circuit diagram, then your writing part is much reduced. So I request you to draw the circuit diagram whenever it is required. Now last question from the chapter. For the copper, the number density of free electron is 4.5 into 10 to the power of 28 per meter cube, and resistivity is 2 into 10 to the power of minus 8 ohm meter. Calculate the conductivity, okay, of copper and relaxation time of free electron in the copper. Take the mass of electron 9 into 10 to the power minus 31, and E value you already know, 1.6 into 10 to the power of minus 19. How to solve it? So first of all, they asked you to find the conductivity. So conductivity is given by 1 upon resistivity. Resistivity is given in this question. So don't get confused, focus. Question is easy, only thing you need to know how to apply your formulas and calculate. So resistivity and conductivity are inversely proportional, in fact exactly inverse. So conductivity will be 2 into 10 to the power of minus 8, that is 0.5 into 10 to the power of plus 8 ohm inverse meter inverse. Okay, ohm meter was the unit, so conductivity will be, both of them will be inverse, ohm inverse, meter inverse. Conductivity part is done. Now next we have to calculate the relaxation time. For that, what we will be using, conductivity can also be given by n e square tau by m. This is the formula that you have to remember. So this is slightly complicated formula, but this is one of the formulas. If you are preparing for this chapter, this is the formula you have to remember. So n e square tau by m. So from there, tau equals to sigma m divided by n e square. Sigma value we have already calculated, 0.5 into 10 to the power of 8, right? Into mass is given as 9 into 10 to the power of minus 31, divided by, now quickly calculate it before me and tell me the answer. Value of n is 4.5 into 10 to the power of 28, and e square is 1.6 into 10 to the power of minus 19 whole square. Let's see who can solve this question faster. So this cancels, you get 2, 2 into 0.5 is 1, so 1 into 10 to the power of minus 23 divided by 10 to the power of 28 into 16 square is 256. So 1.6 square will be 2.56 into 10 to the power of minus 19 square, 10 to the power of minus 38. Okay. So from here we can say the relaxation time tau equals to 1 by 2.56 into 10 to the power of minus 23, and then we have plus 28 minus 38, that is 10 to the power of minus 10 in the division. So it will go up and it will become plus 10 in the upper half. So it will be, now 1 by 2.5 is 0.4. 1 by 2.5 is 0.4. So I am taking approximate value 0.4 into 10 to the power of minus 13. Okay, and unit will be seconds. 0.380. Hi, I am late, Sagar. No, you are late. We have completed 3 chapters, but still we have 5 more chapters to go. So even if you are late, you can still enjoy and learn from something. PDF mood baby, I will send the PDF as I mentioned previously as well. 0.39 into 10 to the power of minus 13. It will be minus 13. Okay, Nagaraj, 0.39 into 10 to the power of minus 13. Yes. Okay. So 0.5 into 10 to the power of 8 ohm per ohm per meter, and 0.4 into 10 to the power of minus 13 second. It is approximated. 3.9 is also fine. 0.39 is also fine. Okay, I have taken approximated value. Okay, so 0.4 is the closest integer, closest number anyway. So yes. So this is the correct answer. Now remember this formula. This is a slightly tricky because of this formula. Okay, otherwise this is an easy question. Next question, next chapter, moving charges and magnetism. Now from this chapter, numerical questions might come. That will be 2-3 marker numerical questions. I am not going to discuss 2-3 marker numerical questions. many students do not attempt that anyway. So if you are interested, you can check my long full length video of 2, 3, 5 marker section video that I have done in the past for this chapter. There I have covered some numerical questions. 5 marker numericals are most important because less number of options are there, so many students struggle in that. So that we will be covering all the chapters which are important. A current I flows along the length of an infinitely long straight thin walled pipe. Then the magnetic field at all points inside the pipe is same but not zero. At any point inside the pipe is zero only on the axis of the pipe, is different at different points inside the pipe. So we have a long pipe which is carrying some current I. Okay, this is a thin wall. Thin wall means the pipe is hollow from inside, like a water pipe. Okay, you have seen water pipe, similar to that. Okay, similar to that, thin walled pipe is there and some current is being passed through the pipe. Okay, now what will be the magnetic field inside this pipe? That is major thing that we are trying to find. What will be the magnetic field? Will it be zero at all points, or will it be not zero at all points, or it will be zero only along the axis of the pipe, or is different at different points? Okay, so Akshay, Sagar, everyone is saying option B. At any point inside the pipe is zero, which is very easy to guess. It is basically from the fact that I dot dl equals to mu naught, sorry, not I dot dl, B dot dl, B dot dl equals to mu naught I, right? Now here, if you consider any closed loop inside this pipe, it does not carry any current because all the current is being passed along the surface. Okay, so remember the charge sphere, all the charges stayed on the surface. Similar to that, all the current here is being passed through the surface area only. No current is being passed inside the pipe. So that means the current inside is zero. So inside current zero means the magnetic field has to be zero. Okay, dl cannot be zero. Dl is a number which is basically the circumference of the circle. So dl cannot be zero. So only B can be zero. So it is zero at each and every point inside the pipe. When a magnetic compass needle is carried nearby to a straight wire carrying current, then the straight wire cause a noticeable deflection of the compass needle. So you have a current carrying wire and you have a compass needle. Okay, compass needle is like this. So when you brought this needle towards this current carrying wire, it gives a deflection. Okay, now compass needle will deflect. The alignment of the needle is tangential to an imaginary circle with the straight wire as its center. So it will be along an imaginary circle with the circle, the straight wire as its center. Okay, so it will be like this. So now the question is, which of them is correct? Both is correct. 1 is correct, 2 is correct, both 1 and 2 are correct, none of them are correct. Okay, neither 1 nor 2 is correct. So easy question. Let's see. Nagaraj is saying option B. Akshay, Nagaraj, Aisha, everyone is saying option B. I think this is for the previous question. This is a different question. Previous question was option B. Yes. Now answer this question. Okay, no one is, I think, responding. They are maybe busy. So the answer for this is the straight wire cause a noticeable deflection of the compass needle. This is a correct statement. Okay, you have learned this in the class 10th chapter, magnetic effect of electric current, where you brought a magnetic needle near a current carrying wire, it gets deflected, and there was a law that it says if you point your fingers in the direction of the current, then the north pole of the needle will deflect towards your thumb, right, if you remember. So that was one of the laws, and it will align itself such a way that it will actually points in the circle. Okay, because magnetic field lines due to a straight wire is basically a circle. Okay, and this axis is basically the center of this circle. Okay, so circular field lines are produced. So because circular field lines are produced, the magnetic field, magnetic needle will always align itself along the tangent. Okay, so statement 1 is correct, statement 2 is correct. So that means both statement 1 and 2 are correct. So option C is correct here. If a current I is flowing in a straight wire parallel to the positive x-axis and a magnetic field is there along the positive y-axis, okay, so we have, suppose this is my x-axis, this is my y-axis, okay, and the z-axis is out of the paper, x comma y is z, okay, 3-dimensional. If you forget, x comma x to y is z, okay, that is the always the direction. Okay, now what is the question? Current is flowing in the positive direction, magnetic field is along this direction, okay, then what is the direction of the force on the wire? What is the direction of the force on the wire? Okay, the wire experiences a force in the negative x direction, negative y direction, negative z direction, positive z direction. Okay, so force basically, if you remember Lorentz force, which was given by Q into V cross B. Okay, now in this case current is being passed in this direction, so we can take the velocity in this direction. Even though the negative electron are passing in the opposite direction, current means positive direction, so we will take the positive direction as well. Don't get confused with negative charges. If you are taking negative charges, then you have to apply the law in a opposite reverse form. Okay, so that's why I am taking the positive direction as the velocity of positive charges. Okay, so this is the direction of current, so you can assume virtual positive charges are flowing in this particular direction. So that is the direction of velocity, and magnetic field is in upward direction. Now how to find the cross product? To find the cross product, first you align your fingers in the direction of the first vector. Okay, you align your fingers in the direction of the first vector, then you curl your fingers towards the second vector. Okay, so I cross B, okay, V cross B or I cross B. I cross B is also correct, by the way. So I is in this direction, B is in this direction, so this will be the cross product. Then your thumb will point towards the force or the cross product of the vectors. So cross product means this is current, this is magnetic field, I cross B, you will get force in the out of the paper, that is in the positive z direction. So wire experiences the force in the positive z direction, so option D is correct, not option B. Right? Yes, Sagar, option D. My chat got slowed down, sorry. Yes, option D is correct. Now next question, a strong magnetic field is applied on a stationary electron. Then the electron moves in the direction of the field, remains stationary, moves perpendicular to the direction of the field, moves opposite direction of the field, moves perpendicular to the direction of the field, moves opposite to the direction of the field. So strong magnetic field is applied to a stationary electron. Very strong magnetic field is applied, so what will happen to the electron? It will move in the direction of the field, remain stationary, perpendicular to the field, opposite to the field. Let's see who can answer. So Karnataka gamer is saying option A, Aisha is saying option A, Karnataka gamer change the option to B, Sagar is saying option B. Karnataka, don't guess the answer A, B, which one is correct? Sometime you are saying A, sometime you are saying B. Gayatri is saying option B. Okay, Akshay is saying option B. So yes, it will remain stationary. Why? Again, if you remember the previous answer, it is Q into V cross B. Now in this case, the electron is stationary, that means velocity is 0. So if velocity is 0, that means it will remain stationary. Okay, as simple as that. Next question. The radius of the circle described by a charged particle moving perpendicular to a uniform magnetic field depends on mass only. Excuse me. velocity only, both mass and velocity, neither mass nor velocity. Okay, so radius of a charge moving in a magnetic field. So what is the expression for charge? If you forget, there is an easy way to remember. mv square by r equals to qvb, or r equals to mv by qb. Okay, so this is the formula for radius. Excuse me, a lot of dust particle is there in the studio today, so that's why. So mv by qb, so both mass and velocity, it depends. So radius depends on both mass as well as velocity. Okay, so option C is correct. Yes, yes Akshay, option C is correct. Now let's look into the 2-3 marker question. Now from this chapter, as I mentioned, no numerical question is there. Lorentz force definition, expression, explain the terms, important. Angular frequency, radius of revolution for a charged particle, the formula derived that I just derived. Excuse me, give me 1 second. So angular frequency, radius of the revolution for a charged particle, important. Force on a current carrying wire, important. Biot-Savart's law, important. Ampere circuit law, important. Galvanometer to conversion, important. Magnetic field at a point on the axis of a circular current loop is also important. Force between two parallel current carrying wire, and hence define ampere. That question is very, very popular in your midterm exam. Now next chapter, magnetism and matter. Quickly answer this question. The expression for motional EMF is, so what is the motional EMF? BVL sin theta, BVL cos theta, BL by V. General expression, most general expression, excuse me, Sir, I am 10th standard and I am topper in my class, sir, by your class. Okay, Karnataka. Excuse me. We have a class 10 channel, by the way, if you are wondering. I used to take classes in that class 10 channel, but now we have dedicated teacher. The link of the class 10 channel is given in our YouTube channel, so you can go and check that out. So motional EMF, normally the formula that we use is excuse me, BVL, but in that case that is the formula. Okay, not sin theta, not cos theta. Give me a moment. It's fine now. Sorry guys, I was slightly delayed because of my sneezing. Yeah. So let's move on to the next question. To induce EMF in a coil, the magnetic flux linking must remain constant, must increase, must decrease, both B and C. So to induce EMF in a coil, what will be the magnetic field? It should increase or decrease or both, or it will remain constant. Easy question, let's see. Aisha is saying option A, Nagaraj is saying option D, Alan is saying option D. Yes. Alan, you told me your name, I forgot your name some time back. I called you alien in the first time, sorry for that. So both B and C is possible only when it is changes. When the magnetic flux linked with the coil changes, then only we see that flux is getting linked. Okay, induced EMF is induced. So only when the flux linked with the coil changes, EMF is induced. So option D is correct. When a magnet is moved with its north pole towards a closed coil, the nearer end of the coil acts as. So a north pole is moved towards a closed coil. So towards a closed coil means what will happen to this loop? What will be the pole induced on this? Will it be a north pole? Will it be a south pole? Or no magnetic field induced? Both north and south pole are induced. Okay, nearer end of the coil. Remember, nearer end of the coil. So that is very, very important. Alan is saying option A, Aisha is saying option A. So option A is correct because when you are trying to induce current, what happens is that this north pole and this north pole, they will repel each other, so that Lenz's law is satisfied. Okay, you cannot create energy out of nothing, so you have to do some work. So in case there is a south pole, then after pushing the north pole, it will automatically get attracted and energy will be generated automatically, which is not possible. So that means only north pole will be generated, so that it tries to repel it. So it will try to stop its cause. Question number 4. The magnetic flux linked with the coil varies as phi is equal to 2t square plus 2t. What is the magnitude of induced EMF at options are wrong. So you calculate the value and tell me the answer. What is the magnitude of induced EMF at t equals to 0.5 second? So phi is given, okay, and you have to only find the magnitude. So that means the negative sign you can ignore. So what is the formula of induced EMF? Induced EMF is d phi dt. Okay, so that is 4t plus 2. So just put the value 4 into 0.5 plus 2, that is 2 plus 2, that is 4 volt. So induced EMF is 4 volt. Yes. Not Alan. Alan, you answered wrong. Yes, 4. 4 is the answer. Yes. Okay. Easy question. Only thing you have to remember that the EMF can also be calculated using this formula. So that's how you can calculate it. Easy question. The magnetic flux through a surface of area A placed in a magnetic field B is defined as B dot A, B cross A cross B, B divided by V. So magnetic flux is defined as. So how you define magnetic flux? So if you remember, I am giving you a hint. It is BA cos theta. Now you tell me the answer. This is the magnitude. So vector form, what will be the answer? Alan is saying option A, Aisha option A, Mohammed option A, Anmol Chopra option A. Yes, it is B dot A. Cos theta means dot product, so it will be B dot A. Now let's look into the 2-3 marker questions. Difference between dia, para, ferromagnetic materials. So you have to, I have done this chapter, also I have covered this chapter where I have done a exclusive table where all these 3 differences are covered, so you can go and check that out. I will be covering again these questions, don't worry. Properties of magnetic field lines, Gauss's law of magnetism, very important question. Magnetization and magnetic intensity, sometimes it might come. Magnetic susceptibility and relative permeability, what is the relationship between magnetic susceptibility and relative permeability, that is also important. No 5 mark questions will come from this chapter, no numerical again. Electromagnetic induction, another easy chapter. I think, sorry, this is magnetism and matter. This chapter is magnetism and matter. Sorry, there is one mistake happened, that the MCQs that we covered in the previous chapter was actually EMI. Okay, and this in this chapter we are going to cover magnetism and matter. Sorry for this mistake. Some jumbled up happened when we are preparing the PPT. Anyway, this is the chapter. The MCQs are magnetism and matter. The long questions will be from electromagnetic induction. Now let's see. The susceptibility of a ferromagnetic substance is greater than 1, 0, very greater than 1, less than 1. Ferromagnetic substance and susceptibility. What is the answer? Which one, Karnataka? Which one I should explain? I explained it already. Option C, option C, option C. Yes. So for a ferromagnetic substance, susceptibility is always greater, very greater than 1. Okay. For paramagnetic substance, it is slightly greater than 1, and for diamagnetic substance, it is less than 1. Okay. Remember it. It will be very helpful. Which of the following properties is false for a bar magnet? It does not produce magnetic field. False, you have to find false statement. It does not produce magnetic field, its poles cannot be separated, it points in north-south direction when suspended, its like pole repel and unlike pole attract. Now let's see, easy question. Yes, Muhammad answered option A. Yes, it does not produce magnetic field, which is a false statement, because magnets will always produce magnetic field no matter what. Okay, even if it is a horseshoe magnet, if it is a bar magnet, it is a circular magnet, any type of magnet will always produce magnetic field. So the magnets not producing magnetic field is a false statement. Now next question, susceptibility of a certain magnetic material is 400. What is the class of the magnetic material? Susceptibility is 400. So it is a diamagnetic material, paramagnetic, ferromagnetic or non-magnetic. Which is the correct answer? So 400 is basically greater than 1. So that means it must be a ferromagnetic substance. Okay. Hurain, Aisha, option, not option A, it is a ferromagnetic substance. Okay. I think you are answering the previous question. Yes. So option, it is greater than 1 means 400, 1400, 4000, it will always be ferromagnetic substance. Okay, ferromagnetic substance has very high susceptibility. If it is, say, probably if it is 10, then it will be a paramagnetic substance, or 40 can also be a paramagnetic substance, but anything greater than that, it will always be ferromagnetic substance. The magnetic field lines inside a bar magnet are from north pole to south pole, are from south pole to north pole, do not exist, exists only when an external field is present. So we have a bar magnet. The magnetic field lines generally is from north to south, right? When you are considering outside the magnet. Sir, how this video will help? Sagar, here we are discussing important MCQs to refresh your memories. All the important questions from the chapter is also, I am sharing it to you, discussion of the questions. You can check out my respective chapter videos, but if you do not have time, you can just check out this video. Here all the important questions are shared. So preparation obviously is up to you, where you prepare from my video or from some guidebook or not. So I am sharing the questions, important questions. From this questions only you will face the questions, that is for sure. And also we are solving numerical questions where students suffer. Okay, so all the numerical questions from the chapters, whenever they have come, I have solved numerical questions from first 3 chapters. We will be solving numerical questions in other chapters as well. As you can see, alternating current and ray optics are still pending. From these 2 chapters we will be solving numerical questions as well. And we are giving you some tricky MCQ questions where students struggle as usual. So magnetic field lines inside a bar magnet is from option B, from south to north. Inside the pole it is always south to north. So option B is correct. Next question, when a bar magnet of dipole moment vector m is placed in a uniform magnetic field B, okay, then what is the torque? Bar magnet of dipole moment m is placed in uniform magnetic field B, what is the torque? Okay, m cross B minus m cross B, B cross m, m dot B. So what is the torque acting on a dipole when you place it on a uniform magnetic field B? Let's see. Option A, option A, option A. Yes, it is m cross B, not B cross m. Okay, not B cross m, or obviously minus m cross B is not answer. It is m cross B which is the answer. Okay, remember the order, m first, B second. Now let's see the 2-3 marker questions. Faraday's law, Lenz's law, expression for self-inductance, coil magnet experiment, motional EMF derivation. These are all the important 2-3 marker questions from this chapter. No 5 marker questions and no numericals from this chapter. Now alternating current, again from this chapter we are solving numerical questions as well. Let's do it quickly. An ideal step-up transformer decreases dash. So step-up transformer means it is increasing the voltage. So if you increase the voltage, then what will reduce? Current, voltage, power, frequency. Now ideal transformer, power remains constant. Okay, in an ideal transformer, power is constant, only current and voltage, their relation changes. Okay, frequency is unaffected, frequency remains the same. So only current and voltage you can change. So let's see who is answering what. Option A, yes. So in an ideal step-up transformer, only current is decreases. Okay, if voltage increases, current decreases. Next, in a series LCR circuit, the L and C are interchanged. The resonance frequency of the circuit will be. So resonance frequency of the circuit is given by 1 by 2 pi square root of L and C. So if you interchange L and C, obviously you can see the value does not change, so it will remains the same. So option C is correct. Let me go through it little quickly because I have to wind it up as quickly as possible. In a transformer, the windings of the primary and secondary coils are wound one over another to reduce the energy loss due to. So in a transformer, when you wound one coil over another, this is because all the flux that is coming out of the primary should also pass through the secondary. This is a way to stop flux leakage. So this is a way to stop flux leakage. Okay, so this is basically reducing the energy loss due to flux leakage. In case of alternating voltage applied to a resistor, the current leads the voltage by a phase angle of pi by 2. The current lags behind the voltage by a phase angle of pi by 2. The current and voltage are in the same phase. The current leads the voltage by a phase angle of pi by 4. So in this particular case, the current and voltage are in phase. Okay, when you apply AC to a resistor, current and voltage will remain in phase. In case of Inductor, it lags behind, so it is lags behind for inductor, and for capacitor it leads. Okay, for capacitor it leads, for inductor it lags, for resistance they are in the same phase. Okay, if you remember these 3 points, all type of questions which is coming from this concept you can answer. The input voltage in a pure capacitor is V is equal to Vm sin omega t. Then the current in the circuit is. So in case of capacitor, as I said, current leads, so I will be equals to Im sin pi by 2 plus omega t. Okay, current leads means it will be omega t plus pi by 2. Lead means plus, lags means minus. Okay, sin omega t plus pi by 2, so this is the correct answer. Next, power loss in transformer is only important concept from this chapter, otherwise theory wise this chapter is not super important. Some resonance based question might come, but power loss of transformer, there are 4 or 5 power losses in a transformer. You remember any 3 of them, that is important. Otherwise theory related questions are not going to come from this chapter, but there will be a numerical questions, and if you are someone who can remember a few basic formulas and want to answer few questions, this is the chapter from where by remembering few basic formulas you can answer all the questions. That's why I always recommend this chapter to my students for MCQs, for numerical questions. A sinusoidal voltage of RMS value 200 volt and frequency 50 Hz is applied to a series RC circuit in which R is 3 ohm, C is 800 microfarad. Calculate the impedance of the circuit, the current through the circuit, phase difference between the current and the voltage. So remember that first thing that you have to answer, find is that the capacitive reactance. Capacitive reactance is given by 1 by 2 pi Fc. Okay, this is the formula for capacitive reactance. Sometimes we can write this as 1 by omega c as well, but this formula is generally not going to come in your PU board exam. For competitive exam this formula might come, but for PU board exam this is the major formula that you have to use. Okay, frequency here is 50 Hz. So we'll just put the values 1 by 2 pi, pi means 3.14. Only thing you need to solve this question, this chapter's question, is the calculator. Calculator is essential. Frequency is 50 and capacitance is given as 800 microfarad. So 800 micro means 10 to the power of minus 6. Okay, so it will be 10 to the power of 6 going up, it will go up. Okay, and then it will be 100 approximately 25. 3.14 into 8 is 24 point something. I can take that as 25 approximately. Now how many zeros? 250 is 100, 2 zeros from here and 2 zeros from here, that means 10 to the power of 4. So here we get 10 to the power of 6 divided by 25 into 10 to the power of 4, that is 10 square by 25, which is 100 divided by 25, that is 4 ohm. This is the inductive reactance, sorry, capacitive reactance. Now capacitive reactance we have calculated. Now we have to calculate the impedance. Impedance is generally square root of R square plus XL minus XC whole square. Now in this case XL is not there, only RC circuit, so it will be simply R square plus XC square, square root of this. Okay, so it will be square root of 3 square plus 4 square, that is 5 ohm. So the impedance of the circuit is 5 ohm. Okay, next is the current through the circuit. So what will be the current? Current will be easy. Current is basically the voltage divided by impedance, Ohm's law. Okay, instead of resistance we will take impedance. So voltage is 200, impedance is 5, so that will be 40 ampere. Okay, so current through the circuit is 40 ampere. What next? Phase difference between current and voltage. So phase difference, for phase difference what formula you have to use is that tan inverse XL minus XC by Z, or modulus of XL minus XC by Z. In this case XL is 0, so XC by Z. Okay, so this is the formula. So tan inverse XC value is 4, Z value is 5. Okay, now this is a non-standard angle, but those who are preparing for competitive exam, this is a very standard angle, which is 53 degrees. 53 degrees and 37 degrees, the two other angles that you practice. So this is 53 degrees. So the answer will be 5 ohm, 40 degrees, 53 degrees. Don't worry, in case you don't know this conversion, you can leave it here, you will get full marks. Even if you leave the answer over here, you will get full marks, because you are not allowed to use calculator, scientific calculator. So you can find it using tangent sine table, but that will waste of time. In my opinion, if you leave the answer here, you will get full marks. Okay, now next question. A resistor of 50 ohm, a pure inductor of 250 millihenry, and a capacitor are in series, containing an AC source of 220 volt 50 hertz. In the circuit, the current leads the voltage by 60 degrees. Find the capacitance of the capacitor. So capacitance is not given, so we have to find the capacitor. So what is the formula for phase difference? I already told you, it is basically tan inverse of XL minus XC divided by R. Okay, for convenience you can take the magnitude. Okay, current leads the voltage means basically what it means to say is that XC will be greater than XL. That's it. Current leads the voltage means it will be XC minus XL. Okay, if you understand it, very good. Otherwise you take the modulus and in the end ignore the negative sign. Okay, otherwise you have to use this XL minus XC. Now this angle is given as 60 degrees. So tan of 60 degrees equals to XC minus XL divided by Z. Divided by R. In the previous problem also I made a mistake. It will be R. It will be 3. Okay. So now XL minus XC by R. Now what you have to do? Tan 60 is root 3. So root 3. Now what is XC? We don't know. XC value is not, C value is not given at all. Okay, what is XL? XL is 2 pi F into L. Okay, so 2 pi, frequency is 50 hertz and L is 250 millihenry. Milli means 10 to the power of minus 3. So you get this as 100, 250, 10 to the power of minus 3, it will be 25 pi. Okay, so XL will be 25 pi. So that is 25 into 3.14, 75, 76, approximately 76. Okay, so let's take that answer. So XC minus 76 we divided by R. So resistance is given as 50 ohm. Okay, so 50 root 3 means 1.7 approximately, equals to XC minus 76. So 50 into 76 means it will be 50 plus 30, 350, which will be 85. So XC equals to 85 plus 76. Okay, so that is approximately 150, 161. So this is the XC value. Okay, you can use the calculator, don't worry, you can use the calculator to calculate values. There is no such mathematics, you cannot calculate without using a calculator. Okay, now what? Now you have to use the fact that Xc equals to 1 by 2 pi frequency into capacitance. Okay, so C will be equals to 1 by 2 pi f into Xc, that's it. Okay, so now put the values, 2 into 3.14 into 50 into 161. Okay, I am taking a shortcut. Shortcut is you have to calculate it and it will be approximately 20 microfarad. Okay, 10 to the power of minus 6 will come anyway. 10 to the power of 6 will come in the division, you can check that out. So once you find the division, it will be 0.00002 approximately. So that will be 20 microfarad. Okay, 20 microfarad is the answer. You can check and tell me the answer. Sir, my ma'am told this chapter is not there for midterm. Sagar, this chapter may be not there for midterm for your particular college exam. As I said, district paper, this chapter will be there. Okay, it was there last year, it will be there this year as well. So as I said, different colleges take midterms differently. Some colleges prepare their own paper, but your district paper is compulsorily, you have to answer that. Okay, so that's why you have to prepare for this chapter. Now MCQs, an object of finite height is placed in front of a concave mirror within its focus. It forms a real enlarged image. Okay, an object of finite height is placed in front of a concave mirror. In fact, electromagnetic wave is also there. Electromagnetic wave is easy chapter, very small, 2-3 pages chapter. I am not going to discuss the chapter anyway. 1 2-marker question or 1 3-marker question might come. Electromagnetic, remember the spectrum which has higher wavelength, which has lower wavelength, that's sufficient for that chapter. An object of finite height is placed in front of a concave mirror within its focus. It forms a real enlarged image. So first of all, it's a concave mirror. Okay, and the object is placed within its focus, means it is placed at a distance less than f. So distance is less than f. So what will happen to the image? Image will be real enlarged image, real diminished image, virtual enlarged image, virtual diminished image. So what will happen to the image in case of a concave mirror? So concave mirror, when you place the object in front of a concave mirror at less than f, it will be forming a virtual and enlarged image. So option C is correct. This is a class 10th question. There was a student of class 10th who was answering few questions. If you are still here, you could have answered it. Identify the statement which is true for a compound microscope in the following. Its objective and convex lens of greater aperture. Objective is a convex lens of greater aperture. Its eyepiece is a convex lens of smaller aperture. The image formed by its objective is real and inverted. Its eyepiece produces a final image which is virtual and diminished. Okay, now let's answer this question together. Objective is a convex lens of greater aperture. Okay, eyepiece is a convex lens of smaller aperture. Now objective is a convex lens, no doubt about it, but if you see the diagram, the aperture of eyepiece is greater than that of the objective. Okay, now the image formed by its objective is real and inverted. So the first image which is formed by the objective is real and inverted. So first image, here is the object, it forms an image real and inverted, and then the final image is being formed by this eyepiece which is a virtual, and it is again inverted and highly enlarged. Okay, so eyepiece is a image formed by eyepiece is real and inverted. Image formed by the objective is real and inverted. The eyepiece produces a final image which is virtual and enlarged, not diminished. Obviously not diminished. Its eyepiece, if it is forming diminished image, that means the whole purpose of the microscope is gone. So it will be virtual and enlarged. Okay, here the option C is correct. Very careful about microscope and telescope related questions. A ray of light is incident on a glass air interface at an angle greater than that of the critical angle for the pair. The ray undergoes refraction only, partial reflection, total internal reflection, grazes the surface at the interface of the two media. So light is traveling glass air interface, okay, glass air, and the angle of incidence is greater than the critical angle. So greater than critical angle means the entire light will come back to the second media. That means it will come back to the first media. That means it will undergo total internal reflection. This is the last chapter, guys. I will close it in next 10 minutes. In case of total internal reflection, light ray must be traveling from rarer medium to denser medium. So for total internal reflection, light ray must be traveling from denser to rarer medium. So light ray must be traveling from denser to rarer medium. Check the other options. The angle of incidence must be less than critical angle. The angle of refraction is 0 degrees when the angle of incidence is equal to critical angle. Okay, this is 90 degrees and this will be greater than the critical angle. So these two options are incorrect. So when answering MCQs, check all the options once. Sometimes there may be two correct options and the third option is both A and B. So to avoid confusion, always check all the options one by one. A ray of light coming from an object which is incident parallel to the principal axis of a convex lens placed in air after refraction appears to diverge from the first principal focus, emerges without any deviation, appears to diverge from the second principal focus, passes through the second principal focus. So let's see. Convex lens. Lens is convex. Okay, parallel ray of light coming from an object which is incident parallel to the principal axis. So when the parallel ray of light falls on a convex lens, it passes through the first principal focus. This is called first principal focus. Okay, this one is second principal focus. Remember that. So first principal focus is when parallel rays are falling on a lens. Okay, so it passes through the first principal focus. It passes through the appears to I think the options are wrong. This is first principal focus. When parallel rays are falling on a lens, the principal focus is first. So either it will be passes through first principal focus or it will be converge. Okay, converge to. It's a convex lens, right? So converge. So I am saying converge to is the correct answer. Converge to first principal focus. Okay, so option A is correct for this question. Now let's see the 2-3 marker question. Sign convention. Remember the sign convention diagram and which side is positive, which side is negative. F is equal to R by 2 derivation. Total internal reflection. Conditions for total internal reflection. What is total internal reflection? These are all important. Telescope. Okay, formula for telescope. Power of a lens. What is power of a lens? Lens maker's equation. Refractive index of a prism for minimum deviation, right? Refraction at a spherical surface. Okay, any spherical surface, normal spherical surface. Lens makers is very, very important, and refractive index of a prism through minimum deviation method. These two are very, very important. Spherical surface can come from time to time as well. Now let's solve few numerical question. An equilateral prism is made of glass of unknown refractive index. A parallel beam of light is incident on a face of the prism. The angle of minimum deviation is 40 degrees. Find the refractive index of the material of the prism. If the prism is placed in water of refractive index 1.33, find the new angle of minimum deviation of parallel beam of light. Now this chapter, the numerical question from this chapter can be tricky. Okay, same as current electricity, the numerical questions from this chapter can be tricky. So if you are practicing this just to be a backup option, this should not be your main option. Okay, this should be a backup option for numerical questions. Okay, so what is the formula for refractive index? Formula for refractive index is sin A plus delta by 2 divided by sine A by 2. Now, what is A in this case? So, A is not given. So, how to solve it? So, if you see the question, it is called an equilateral prism. So, equilateral prism means the angle of prism is 60 degrees. Equilateral prism means all sides are equal. That means the angle of prism is 60 degrees. Now, let us put those values. Sine 60 plus 40 divided by 2 divided by sine 60 by 2. So, it will be sine 100 by 2, that is sine 50 degrees divided by sine 30 degrees. Okay. Now, sine 50 degrees value is not easy. Okay. So, what we will be doing, we will take this value approximately to be 4 by 5 because it is closer to sine 53. This is the sine 53 degree value. Okay. So, this is what we are going to take. Sine 30 degree is half. So, we get this value of refractive index to be 8 by 5 or 1.6. So, refractive index of the medium is 1.6. This is approximation. Obviously, because we are not allowed to use calculator, sine 50 degree is 4 by 5. Normal calculator cannot calculate sine 50 degree value. So, either you can use the sine table, sine chart, or you can take the approximated sine 53 degree value, which will be approximately 4 by 5. So, from there we calculate the mu of the prism. Now, the thing is, when you are immersing it into the water of refractive index 1.33, find the new angle of deviation. Okay, so new angle of deviation, how to calculate? Okay, so first of all, what is the relative refractive index? Relative refractive index is the refractive index of the prism divided by the medium on which you have immersed it. So here it is water. So mu divided by mu water is the new refractive index of the medium. So it will be 1.6 divided by 1.33. Okay, or it will be 8 by 5 divided by 4 by 3. So it will be, I am just simplifying it, 8 into 3 divided by 5 into 4. So it will be 2. So it will be 6 by 5. Okay. So 6 by 5 is the new refractive index. So now we will use the same formula, mu r equals to sine A value will remain unchanged, but delta value will be new. So I am just adding a dash by